So we've done a lot of work with waves and simple harmonic motion and all of those things. Today, I want to start looking at really how your cell phone deals with this signal. And what does that signal actually look like? So let's think about all the things that have to happen to get that signal from my phone all the way to New York to my grandma's phone. So here's just think about this a second. So the voice goes into the phone. We're comfortable with that. That signal then has to go through several different stages to get over there. It's almost like a game of whisper. If you've ever played that game where you whisper a secret in somebody's ear and then they whisper it in somebody else, they whisper it in somebody else, they whisper it. By the time you get to the end, does that signal or does that message really, is it the same thing as what it started with? That's extremely important with cell phones because your cell phone has to talk to the tower. So that's that first whisper. It's got to talk to the tower. That tower has to talk to the other tower or possibly some other things in between. Then it gets to that other tower in New York. Then it has to go from that tower to, it has to whisper or send that signal back down to the other phone. That game of whisper, that game of secret message is extremely important that we get it right. So let's talk about what that signal really looks like. We actually know what this signal looks like from previous activities. When we dealt with Audacity, if you spoke into the computer, you probably saw that it created a wave that looks something like this. This is the changes in voltage that your phone was getting from the vibration of that coil of wire near the magnet. So the diaphragm, the sound hits that diaphragm, vibrates the coil, and the voltage or the electricity goes up, the electricity goes down, back and forth. And we were able to create this wave. Now this wave is called an analog wave. It is a wave that fits perfectly with how that coil had moved. In a graph form, you might look something like this. Now, if I take this analog wave and whisper it to somebody else, and whisper it to somebody else, and whisper it to somebody else, it's going to actually degrade a little bit as it moves through. I know this from when I was a kid. When I was a kid, we used to have cassette tapes. And cassette tapes actually were a magnetic strip that held that analog wave. So you can imagine the electrical energy is going back and forth. That they would create a magnetic field that would go back and forth, and then that magnetic field, the movement of that magnetic field was actually printed on this cassette tape. So that was an analog signal. And it was really cool. I had stereo, and you had two different cassette tape players, and you could actually play it in one and record in the other, and then you could, what we call dub a tape. And back in the day, we'd always make mixtapes for our girlfriends and all that kind of stuff. Because you could do this with these cassette tapes. However, the copy of the cassette tape was never actually as good as the original because you had to create the magnetic field, it creates electricity, and then that electricity goes to the other part, which then creates a new magnetic field. There's always a little bit of degradation or degrading of the signal as you went through. It was never as good. And we don't want that with cell phones. So with cell phones, they actually use a code. Today, you're going to be taking an analog signal, which is a graph, and you're going to be turning it into a code. Now, when I say a code, I mean numbers, letters, some kind of quantized figure, some type of actual, like a number or a letter or something. That's what I mean when I say a code. If I send this signal across the country, it's going to degrade as I get across. But if I can send a set of numbers and letters, 4, 7, 6, 3, 4, that's not going to degrade. Those numbers will make it to the other side. And then if that other phone knows how to take those numbers and recreate that analog signal, then I'm in good shape. So cell phones actually send a digital code. Digital comes from the word digit, meaning quantized, meaning specific, finite values that it sends across. So your job today is to take an analog graph, and I have a bunch of them for you to choose from, and you're going to make a code out of it. So let's talk a little bit about how to do that. So on your document, you're going to see that there's a link to another document that has a bunch of graphs. If you're in class with me, we're going to do this pen and paper. You're going to actually do it. If you're at home, you can do it pen and paper, but you just got to pick a graph. So go to that other document with a bunch of graphs, like 7 or 8 graphs on there. Just pick one. It doesn't matter which one. You're going to take that graph and you're going to make a code out of it. Now remember, whatever code you make, someone else, that other phone, has to be able to take that code and redraw the analog graph, which means you better write some rules. Write some rules on what your code actually means. Now, I'm not going to tell you how to do this because it's kind of a good exercise in doing this in order to come up with your own code. So come up with some kind of a way to take that graph and turn it into numbers and letters. Be sure that you write very specific directions on how those numbers and letters where they came from, and how to get them back to the digital code. Then what you're going to do if you're at home is you're going to post your code and your directions, because your code means nothing if it doesn't have directions. You're going to post your code and your directions to a discussion board. So we're going to have a bunch of people, after they've posted their code, that's on the discussion board. So then you are going to go to that discussion board, find somebody else in the class's code, I don't care whose it is, and you're going to see if you can't recreate the graph that they did. And it'll be one of those 8. So can you recreate that graph, and then can you pick which one of those 8 graphs is the one that they wrote the code for? If they wrote a good enough code and good enough specific rules, you should be able to figure out and draw very closely what that graph looks like. So have a good time. I'm not going to go in over how to do this. I'm going to do that in the next lesson. But have a good time. Put a lot of thought into this because this is a very important part of thinking about the signal that the cell phone actually sends. I'll see you next time.